Hey YouTube, so welcome back. This is a new series that I'm starting for data structures in Golang. So we're going to go over some of the basic data structures that we can implement and slowly move to some of the more advanced data structures, some of the more complicated ones that we can implement. And we're going to be using Golang as our language. And I'm going to be honest here. I am more comfortable with Python as my primary uh, programming language, but I'm going to be using that as a reference for explaining all of the data structures. So we're going to start from the absolute basics. We're doing a singly linked list in this video. So I've got an empty directory here, so I'm going to quickly initiate Golang project. So I'm just going to do Golang data structures. So I've initialized a project here. I've called it Golang data structures. I'm also going to create a new main.go file. So let's just jump into the main.go, create a package. Now let's just try to understand what a singly linked list is. And I'm going to also create a main.py file where I'm going to like use this as a reference to explain what a linked list is, and then we're going to implement it in Golang. So a linked list is basically a structure where we have a bunch of nodes. Each node has a value and a next pointer, and the next pointer is basically going to point to either none or it's going to be another node. So this whole structure is what we call a linked list. Basically, so at the end, since we don't have anything after that, so it's just going to point to null. Uh, so this is essentially what a linked list is. Uh, we have a bunch of nodes, and each node is going to point to another node which will be stored in a completely random memory location. It's not like a vector or an array where we have a contiguous block of uh, memory where each item is uh, right next to the item that was before it, and so on. So all of this would be all of these values would be allocated in a contiguous block of memory. But a linked list is not a contiguous block of memory. It's one block of memory that's pointing. It's one like value stored in memory, which is associated with a pointer, which will point to a completely different block of memory. If we want to implement this in Python, what we would do is we would create a node, and each node would have a value associated with it, and this we can store anything in this. So uh, it can be anything. And the next pointer would be a node. Uh, so this is what a node would look like. Uh, so we have a value and a next pointer. And if we wanted to have a linked list, or what it would be would we would have a head node. So I didn't mention this. So So the first node in a linked list is called the head of the linked list. And we use this to keep track of the beginning of the linked list. So let's say that if the linked list is this, then in our case, this would be the head node. Or in some cases, what we do is we create an empty node and call this the head node. So we would have a head node. We want to keep track of the beginning of the linked list. We could have the length of the linked list. We can keep track of that, and that would be an integer. So this is mainly what a linked list would look like. We can also have uh, like if we want to create a new node, then we could have like a new. Uh, it would be something like a static method where we pass in a value. and we would get back a node, and this value could be anything, uh, and we would return a node where we have the value, and the next would be none. And we haven't implemented the init method. That's why we're seeing this. What we can do to fix the errors is just make this a data class, and that way we don't really have to implement the next node, and we can make this an optional because the next node, as I said, it can be none or it can be uh, like another node. So what's beyond that? We need optional from there. So yeah, that fixes everything. So the next could be a none or it can be a new node, and new will be something that returns a new node. And we could have a new method here as well. If we wanted to do that, we would just create another static method which would take a new, and we can like create an empty new linked list, or we can ask the user to insert a value here. Let's just create an empty linked list for now, which so we would return a linked list and which would have the head as none. So we'll need to make this optional as well. So we would have none here and we would have zero there. Cool. So this is what super simple linked list would look like in Python. So let's just try to implement a similar simple linked list in Golang. So what we could do here is create a node dot which would have a value. Let's just have it as an int for now, and we will have a next, which would be a pointer to the node. Now, if you compare what we had in Python and what we have in Golang, you would notice that here we are having to mention that this is going to be a pointer to the next node, and we don't have to do that in Python because Python is a dynamically typed language. So basically, all of that stuff is evaluated at runtime. So at runtime, the interpreter would automatically figure out that, okay, this is uh, another node, so this will be a pointer to the node. So we don't have to be explicit about that like we have to do in Golang. So that's a node. We can create a new function similar to what we've done here in Python. So to do that, we can just create a regular function because we can do something like uh, this, but we're not going to do that right now because what this syntax means is that let's say we want to insert something into uh, the linked list, or like let's say we want to uh, clear the value from the link from this node. So in that case, what this syntax means is that we are calling this function on an instance of the node. And we're not going to do that when we are creating a new node because we don't have an instance of the node yet, which is why we have created a static function in Python as well. What static really means is that we can call it this way. We can pass a value something like this, and we can create a node like this. We don't really have to have an instance. Now, node is an instance. Now, if we wanted to clear something, now we would call it on the instance of the node. And so that's similar to like what we have here. We don't really need to have call it on an instance, the new function. So we can just create a regular new function which would take in a value, which would be an integer, and it would return a node. So let's see. We'll create a node which would be the val which is passed. The next would be nil, and this would be our function. Now, in a similar way, we can create the linked list as well, which would also be a struct. It would have a head node, uh, and which would also be a pointer to a node, and we would have a length, which would be an integer, and we can create a new function for that as well, uh, where we have an optional So we can give this a better name, something like new node, and we can call this a new linked list. So first we need to create a head node by calling new node. We can pass in the value that was passed by the user, and then we return a linked list where the head will be the head, uh, and the length would be one. Instead of passing the node instance itself, what we can directly return a pointer to the node, and that is what how we can uh, do it. So this ampersand, what it'll do is it will return a reference to the node, and that's what we're doing here. So it will be a pointer, and we can directly assign it to the head. So now we have something that's similar to what we implemented earlier in Python. Uh, so the next operation which we would naturally perform is inserting into the linked list. So our new method that we implemented earlier, that would be helpful here. So uh, we could have something that would look like this, where the insert method, it will need an instance of the linked list, and we can pass a value to it. And let's think about how we want to implement the insert, because there are multiple ways of doing this. So we can either like replace the head node with whatever the new node that the user wants to create. So it would be something like this, where the new node would become the new head, and it would start pointing to the old head. We can either implement it this way, or we can have it this way, where whatever the head was, that will remain intact, uh, and let's say the head is pointing to a bunch of different nodes. So we would create, and at the end we have a none here. So whatever the new node that the user wants to insert, we can create a new node here, which would be the val and the next would now point to none. And I think this makes a lot more sense to me when it comes to insertion into a linked list. Either way, we can also do it the other way, where we create the new node and we make it the new head. Uh, I mean, it depends. Like that would so it really depends on what kind of a structure that we are trying to build. So what I'm going to do is we can create like both of these methods. We can do something like uh, insert end, and we can have something like insert uh, head, or insert start, insert end, something like that. So start would mean that so this method would implement it the way we mentioned earlier, where it would insert all the way at the end of the linked list. So this would now be the new node. Uh, and in this one, we create the new node as the head, uh, something like this. So this is what we are trying to implement. Uh, so let's just do that. It should be pretty simple. So we can do something like while self dot, or we can do this where we create a pointer for which would have self dot head, and while pointer dot next, we just do pointer equals pointer dot next. So while there is a next for the node, we just move the pointer forward. So we are doing something like this. We're moving forward while there is a next node. So as soon as we hit this, there will be no next node. So this is where the pointer will end. That's where the while loop will break. Pointer, and yeah, that should work. So what is self dot head itself is none. So if it is, then we just have uh, the pointer there. Or we can have a separate case where I forgot where we are having the head as optional as well. So if pointer is none, then this will be where we want to insert it, or and we can have an else there. Makes sense? So what we can do is if the pointer itself is none, then it means that we don't have a head. And in that case, what we can do is um, create a new node, and this would have a value, and that would be our new head. And in this case, where it's not none, which means that we have a linked list with a head and a bunch and zero or more next nodes, then we move the pointer until we have the last node, and then at the last node, what we can do is we can do pointer dot next is a new node with a value. Okay, so this would create a node at the end of the list for us. And similarly, we can do it for the beginning. The beginning should be even simpler because if self.head is none, then we just create a self.head directly. Uh, Else, we would create a new node. It would be it would have the value, and then let's see. We make the next node of the new node as self.head, and we make the self.head as the new node. Makes sense? So you created a new node. Uh, in the case where there is a head and we have zero or more nodes after the head, uh, what we do, if there is no head, then we just create a new head. If there is a head, then we move into the else block, we create a new node, and we set the next of the new node as the head, and uh, we make the head as the new node. So now the next node of the new node would be what we had earlier as the head. Now we want to implement this in Golang, so I think what we can do is we can create something what we saw earlier, where we associate a function with the type, with an instance of the type. So this function can be called uh, insert star. So this function can be called for an instance of the linked list. So if we had an instance of the linked list, we could, if we have something like this, we need to create a main function properly. So we can call insert start here, where we can insert more stuff into the same linked list. So that this is how we can call the function that we're creating now. So this would also be similar. We're inserting at the beginning of the linked list here, and similarly we would have the insert at end as well. And in this case, we would, uh, if there is a head node, then we just create the head node. And if there's no head node, then we loop all the way to the end of the linked list and we create a new node and we attach it uh, at the end of the node, at the end of the list. So first we'll need to check if l.head exists. Uh, so we can do something like this. If it is nil, then l.head equals new node uh, where we pass the value. Let's see. So we are asking the user to insert a value here, in which case there would always be a head node, which is not like we did it in Python. So to make it similar to Python, where we allow users to create a new node with an empty head, we can allow a reference to the value, and we dereference that when we create a new node. And we first will need to check if this is also nil. If it is nil, then let's see what we're doing. So we're creating a new linked list with the head as nil and the length as 0. Uh, we return that, or we don't even have to do or because they're directly returning this. So if this is not the case, then it will just pass on here. So now we know that uh, we can do that. So to now pass the values, what we need to do is we need to do something like this, where we pass the reference to whatever value we want the head to be. And this can be nil as well. We can directly pass nil actually. So we can do something like this. But now the head would have a nil value. And whenever we insert, we'll also check if the head is nil. If the head is nil, then we'll just create a new node and make that the head. Or uh, and we can just return out of here, or we can have an else case here. So in this else, what we can do is first we'll need to create a pointer to the set, I mean L dot head, and while pointer dot next is not nil, we will loop through. So we'll do pointer equals pointer dot next, and at the end we will assign pointer dot next because now we're at the we're at the last node of the linked list. So we'll be creating a new node here with the given value. So this is what we implemented here. And we'll do the same thing which we did in Python here as well. So to insert at the start of the list, we will again have to check the same thing. So we can just copy and paste that. Uh, and in the else block, what we will do is we will create a new node, which will also be a new node with the value. And now we know that there is a head, so we want to make the new node as the new head. So we do new node dot next is L dot head, and L dot head is the new node. Now to test all of this out, we will need uh, a print function. So we can implement that in a similar way. We can have like a linked list, and we'll need a print. We don't need a value there. It'll just be format dot print line. So we can do something like this where we initialize a pointer as the head, and while pointer dot next is not nil, uh, we just do we just print whatever we have in the pointer dot val, and then we'll do pointer dot next pointer equals pointer dot next. Just compare the pointer to nil, and while uh, the pointer is not nil, we print pointer dot value and we go to the next. So if we add a bunch more values to our linked list and then print it, you see that we're getting all of those values. But yeah, we're doing insert start, so that's why we're seeing this. Now let's make it a little bit better. Let's make the print a little better. Let's make it look like a linked list. So let's see, we can have like a print line here, which will be doing that. So yeah, this looks a lot better. So when the list is empty, if we were to print it before we added anything to the list, we will see that the list is empty. And when we added a new element to the start, we saw that now we have a head and which is pointing to nil. And then we add another element to the start of the linked list. So that's that. We have, let's see, why is the node repeated? Yeah, so when we print the value here, we need to do pointer equals pointer dot next, or we can bring this first and then print the next value. So this should work better. Now we see the first element of the list pointing to nil, then the new first element of the list pointing to the next element, which was earlier, which is pointing to nil. Now uh, let's try out the insert end function. Now this could be something like that. We print it out. Yep, so it works. We have inserted at the end of the list, which is now pointing to nil. So this is a better representation of what a linked list would look like. We can do the same thing in Python, but I don't think we will be doing that. Because our aim is to implement all of that in Golang or in Python. We're just using Python as the reference for pseudocode and prototyping the whole linked list. Now we can implement the delete method of the linked list. Now the way we can do that is quite similar to how we did the insertions. We can also delete start and delete end. That's also something we can do. Uh, so we can have something like this, where we have a separate method for deleting from the start of the linked list and a separate one for deleting from the end. Delete start, what it would do is whatever the so first we'll need to check if the head is nil. Then we just return. We don't need to do anything in that case. If that's not the case, and if there is a head, then whatever the head is, we will need to assign it head.next. I think this should be enough. Like we're assigning the head to whatever head.next is, and this should be like whatever the current head was, it should get garbage collected after this point. So this condition is bothering me a bit. So what we can do is instead of checking if it's null, we check if it's not null, and in that case we just perform the operation. This is a lot cleaner, in my opinion. And in the case where we are doing it for the end, we have the same condition where we check if it's not null, and in that case we perform our operation. So we'll have to have a pointer which would be at the head. And I always forget the the assignment operator there. So for pointer is not equal to nil, we just do pointer, or we can do pointer dot next is not nil. We would do pointer equals pointer dot next because we want to be at the node, which is we want to be at the last node at the end of this loop, not nil. We don't want to be at nil. We want to be at the node whose next is nil, which would be our last node. Uh, or I don't think we want to do that either because we don't have a back pointer. This is a singly linked list, so we don't have a pointer to. Let's say we are at the end of the list. Let's say if our list is this. So we want to right now the way the loop is working is that at the end of the loop we would be at 2. So there's no way of having access to the node that was before that. We can do that by having like two pointers. You would have a pointer 1 and a pointer 2. So let's just do it that way. We'll have a pointer 1 and a pointer 2. Pointer 1 would be head and pointer 2 would be head.next. And we would loop while pointer 2 is not nil. And in this case, we would do pointer 1 equals pointer dot next, or we can do something like pointer 1 equals pointer 2 and pointer 2 equals pointer 1 dot next. So if we go over this a little again, we initialize the pointer to the head, pointer 2 would be next, and all of this is being done only if head exists. And we loop while pointer 2 dot next is not nil. And we can have a check here as well, like what if the head uh, is the only element in the list. It's the only node in the list. So if pointer 2 is nil, then we just set head to nil because if you think about it, pointer 1 is not nil, pointer 2 is nil. Then we just want to set pointer 1, which is the head, to nil. And we would just return, uh, or we would go into this loop where we're now checking if pointer 2 has a next, and while pointer 2 has a next, we just do this, and at the end, we just do pointer 1 dot next is nil. So we have deleted pointer 2 after we've done this. So at the end of this loop, we now know that pointer 2 is at the last position of the linked list because the next is now nil, and pointer 1 is the node before pointer 2. So we just set pointer 1 dot next to nil, and pointer 2 would just get garbage collected. Uh, let's just try this out. So linked list dot delete start and print the linked list. Okay, so we see that 1, 2, 3, 4 got deleted, and we have this list. Now let's try to delete from the end of the list. So this also gets deleted. So we have a functioning linked list at this point where we have we have the ability to create nodes. We have the ability to delete nodes. We are able to control the nodes which are at the beginning of the list and at the end of the list. And this is pretty handy for creating complex data structures like anything like stacks, graphs, trees, so on. So this can be used to create any of those. So in the next video, we will be trying to implement a doubly linked list, which would have a forward pointer. In this case, we only implemented a singly linked list, which is only having the next pointer. But in doubly linked list, we would have a previous pointer, which would and which would allow us to go both ways, to traverse the linked list both ways. So this will help us create like, as opposed to having a unidirectional graph or something like a tree, we can create like if with this type of a linked list, we can create a tree pretty easily, but it would be difficult to create a graph which is non-directed. A directed graph can be created with this, but what if we want to allow like traversal both ways? In which case, we will have to have a previous pointer as well. So we'll be doing that in the next video. So stay tuned. Thanks for watching.